was day like any other, except it wasn't. I was in my office as usual, finishing up a case, when man walks in, distraught. He's clutching papers in his right hand, pencil in other. I ask him what's wrong, and this sucker, he stares me in the eyes and asks for help. I say, alright, I've seen worse. So I grabbed the papers from his hand and could immediately tell what was wrong. The paper was algebra 2 homework. I was taken aback at first, but I knew this man needed help, so I shooed him off so I could finish it. But bartender, I've been sitting here for hours, and I still can't decipher it. Quite the predicament you've got yourself in there, Sonny. Let me take a look. I see. It's impossible, Tender. I have solved hundreds of cases before, and not one has stumped me like this one has. Well, I say, this is quite easy, really. What? You've been doing it all wrong. Give me that pencil. You see, this is simply just taking out the GCF and solving using the quadratic formula. First things first is to take out the GCF. In this case, we'd be taking out a 2x. The 2x goes on the outside of the parentheses, and now on the inside we have a quadratic equation. To review, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a and c divided by 2 times a. Let's plug those numbers in. You'll want to start with what's inside of the square root. 8 squared really is just 64, and negative 4 times 3 is negative 48. Subtract those two and it gives us 16. The square root of 16 is 4, so that leaves us with our equation, 8 plus or minus 4 divided by 8. The next step is to solve for x. To do this, we write out two separate equations, one with the minus sign and one with the plus. That's because of the square root. Solve these two respectively, and you get 0.5, 1.5. But that's not all. We still have to solve the 2x on the outside. Equal 2x to 0 and solve. The answer for that is simply 0. And that leaves us with the final answers of 1.5, 0.5, and 0. No wait, thank you, bartender. I gotta go. My client needs to see this immediately. Anytime. And they said I'd never need you.